Let's talk briefly about heat and temperature. So these two words are something that we use fairly interchangeably in our everyday language, but in physics they have a very specific meaning. Temperature is something that's relatively easy to measure because we just have these things called thermometers which measure temperature, but it's measuring something quite abstract. And it's illustrated here with this simulation. So here's a gas of particles, and it has a temperature. In this case it's 55 Kelvin. And that temperature is really a reflection of some microscopic property, which is the motion of the actual atoms themselves, the atoms and molecules. So the more that those things are moving, the more sort of internal kinetic energy this object has. That, it turns out, is what's reflected in the temperature that we read on a thermometer. Okay, so temperature is this measure of internal kinetic energy, the motion of these particles. Alright, by contrast, heat is an amount of energy that can be put in or removed from an object. So one distinguishing factor between heat and temperature is that heat is energy, so it's measured in joules, or as we'll see in other related units like BTUs or calories. But it's the same kind of energy that we would talk about before, whereas temperature reflects some sort of energy, like this kinetic energy, but it's not a direct measurement of the energy itself, right? It's this sort of bulk motion. Okay, so heat is energy. That's one distinguishing factor. The other distinguishing factor is that while temperature is a property of something, like at this moment this gas has a temperature of 55 degrees, heat is more about transition. Heat is when something is entered or removed from the system. So I can add energy by applying heat, and you'll see it reflects in a raised temperature. Alright? But the action of adding energy is what I would refer to as heat. Or by contrast, removing energy would also be sort of a change, like applying heat. It'd be negative heat, if you will. Okay, so removing energy. Alright, so heat is this change in energy, whereas temperature is this sort of indirect measurement of an internal property. All right, it's kind of a weird distinction. Hopefully, it makes more sense as you read through the book. The other thing I want to mention is that there are we refer to as three different methods of heat transfer, three different ways that you can add energy or remove energy. And let me just illustrate those for you with some helpful illustrations. The first is called convection. And while there's lots of examples of convection in weather, in the inside of the earth, I think one of the most helpful illustrations of convection is the lava lamp. Right? So the idea behind convection is that you have heating taking place at one area. In the case of a lava lamp, it's at the bottom. And then something gets heated, and as it heats, it's like hot air rises, right? It starts to rise. And so the hot stuff goes up, and so there's a transfer of energy. There's heat that's rising up here, right? So that convection process, the movement of a warm material. And then when it gets up here, it's cold, and so then it starts to sink back down. And so you get is a convection cycle. So that's one way in which heat can be transferred. Another way that heat can be transferred is by radiation. So the picture to have in mind is somebody laying out on the beach, or perhaps a sea lion laying out on the beach, being warmed up by the sunshine, right? This light energy that's coming from far away. Radiation gets absorbed by the dark skin and adds energy, right? Adds heat, warms up the temperature. Okay, and the third heat transfer that we'll talk about, method of heat transfer, is conduction. And that's whenever you have two things actually touching each other. So the picture to have in mind here is a stove top. Right? So I'm looking at the actual stove top here, and if you want to make something get hot, like your pan, you actually touch the metal pan against the glass top, and it gets really hot. So there's actual contact. There's no bulk motion. There's no radiation. It's direct contact, and the heat is transferred that way. In fact, I like this last picture because our standard kitchen appliances actually illustrate all three methods of heat transfer. The stove top illustrates conduction. The stove itself, the oven, actually illustrates convection because there's a heat source at the bottom, and then there's sort of a circulation of air that takes place there, convection cycle. And of course our microwave uses radiation to actually heat up food. So all three of the methods of heat transfer are actually illustrated in this one picture. All right, so that's just a quick introduction to the topics you're going to be reading about in these first few sections of Chapter 14.